This is a continuation of the exercises on ellipses from the printed handout, and I think we already did 1 and 2 were to exercise number 3, so we're going to start working on number 3 together here. And there we go. And so we're graphing another equation, 4x squared plus 9y squared equals 1. And what might not be obvious right away is this even the equation of ellipse? It doesn't seem to have those fractions, x squared over number squared plus y squared over number squared equals 1. You might try to put it in that standard form. I can see why it might be tempted to, since 4 times 9 is 36, it might be tempted to divide both sides by 36. Let me show you what would happen. So I'm dividing the left-hand side by 36. I'd have to divide the right-hand side by 36. And then you can reduce, you can do some canceling. So we get x squared over 9 plus y squared over 4 equals 1 over 36. But we don't really like this. This isn't so good because this is not standard form. And so it's not useful. Standard form requires a 1 on the right-hand side. So we don't have our 1 on the right-hand side. We have 136. So this is just not useful. And the point I want to make here is we're just going to go back to this original equation. There's actually, there's no need to put the equation in standard form. To put the equation in standard form. What we can do is we're just going to plot the x and y intercepts from what we have, what we are given originally. So I'm just going to go ahead and work with that 4x squared plus 9y squared equals 1. And I think we're going to get all the way through the graph that way. At the end, we might go back and just talk about what standard form for this equation would look like. But let's go ahead and start trying to find these intercepts. So our x-intercept set y equal to 0. So I'm going to take this original equation, 4x squared plus 9 times, I'll say 0 squared equals 1. So I have 4x squared plus 0 equals 1. 4x squared equals 1. And here, before I take square roots, I want to isolate that x squared. So I want to divide both sides by 4. And I get a fraction, x squared equals a fourth. Not too bad. X will be plus or minus the square root of a fourth. And that square root will simplify to plus or minus a half. So 1/2, 0, negative 1/2, 0 are the x-intercepts. And see, I got those just fine from the form of the equation that I was given. Let's also find the y-intercepts, and that'll be very similar. I'm going to, again, go back to the original equation and set x equal to 0 now. 4 times 0 squared plus 9y squared equals 1. 0 plus 9y squared equals 1, and it's a very similar kind of calculation here. So I don't want to take square roots until I isolate y squared. So I want to divide both sides by 9 to get y squared equals 1/9, then take square roots, and I get y is equal to plus or minus 1/3. So 0, 1/3, 0, negative 1/3 are the y-intercepts for this graph. And now let's, I'm just going to go ahead and plot. Let's see what we got here. And because I'm getting fractions, I think what I want to do is 1, 2, 3, 4, 5, 6, 7, 8, 9. I think I can just about fit it here. I think I'll fit it on the bottom. 5, 4, 3, 2. I'm going to put my x-axis here. What I'm going to do is I'm actually going to count by 0.1, 0.2, 0.3, 0.4, 0.5. So this is 0.1, and draw my, so I'm changing the scale. I'm making the size of each square 1/10 or 0.1 because I have these fractions to deal with. This isn't the only way to do this. So this is negative 0.1. And same thing to the right. I'll go 0.1, 0.2, 0.3, 0.4, 0.5. That would be 0.8, I guess. 1, 2, 3, 4, 5, 6, 7, negative 0.8. And that's negative 0.5 down there near the bottom. So if I want to plot my x-intercepts 1/2, 0, negative 1/2, 0, that's 0.1, 0.2, 0.3, 0.4, that's 0.5, right? So that's going to be right here, 0.5, and 1, 2, 3, 4, 5 right here. And my y-intercepts at 1/3, negative 1/3. 1/3 is about 0.333. So it's a little bit beyond 0.3, a little bit below 0.3. And once I get those intercepts, I can draw my ellipse. Okay, I'm a little wobbly today. All right, now what we still want to find here, though, is our focus, our foci, and I think I need some more paper, so I'm going to put my picture up there and add some more room down below. So finding the foci now, what we have to do is we have to use our a squared minus b squared equals c squared formula. And to do that, I got to figure out which one of these is the a and which one of these numbers is the b. Now I can use my intercept values, and remember we had this is 0, 1/3. Right here is 1/2, 0, right, on the x-axis. I need to think about which one of those is larger, because the larger of those two intercept values is going to be a. 1/2 is actually larger than 1/3. So a squared is going to be 1/2 squared. Minus b squared is 1/3 squared. That's equal to c squared. And now again, how did I know which was a, which was b? It's really just the larger. 1/2 is further away from the origin than 1/3, so 1/2 is bigger than 1/3. And I get 1/4 minus 1/9 is c squared. Common denominator is 36, so I got to multiply 1/4 by 9 above and below. 1/9, I got to multiply by 4 above and below. Sorry. And I have 936 minus 436 equals c squared. That's 536 equals c squared. So when I take square roots, I get plus or minus 5/36 is c. That's plus or minus square root of 5/6 is c. So now my foci are going to have square root of 5/6, negative square root of 5/6 as coordinates. But now, are we on the x-axis or the y-axis? Well, from my graph, I know the major axis is the x-axis. So x-axis is the major axis. So the foci lie on the x-axis. So these must be x-coordinates of points. So the square root of 5/6 goes in the first coordinate position, comma 0. Negative square root of 5/6 goes in the first position, again, negative x value, 0. And those 2 points are going to lie on the x-axis. It helps to use a calculator to get a decimal here. This is square root of 5/6 is about 0.37. I got that on my calculator ahead of time. So let's go back to our graph now and add our foci. They're on the x-axis. They're about 0.1, 0.2, they're between 0.3 and 0.4. So they're here and here. I guess I'm going to label these maybe F and F prime so I don't have to recopy the coordinates on my picture because I'm tight for space. This point is my F prime point is right here. This one is my F because I put the F at the negative coordinate. So here's one focus. Here's the other focus. And I think we have everything on our graph here for this ellipse. But now, I want to say a little bit more. We actually are done. We got our picture drawn. We've labeled, we got our vertices and our foci all labeled. But now, what about the standard form of this equation? So let's go back to that 4x squared plus 9y squared equals 1. And let's just ask ourselves the question, what is the standard form? And the standard form should have that a squared and that b squared in the denominator, correct? And our a squared is 1/2 squared is a fourth. Our b squared is 1/3 squared or 1/9. Those would actually be fractions in the denominator. So what I want you to see, now you don't have to actually do this, but I just want you to see, I can write this as 4x squared over 1 plus 9y squared over 1 equals 1. Because I don't want to change the one on the right-hand side, I don't want to do something to both sides of this equation. But what I can do is, in order to just change one fraction, I can multiply above and below by 1/4 on this fraction. Here I can multiply above and below by 1/9. And that doesn't change the value of the fractions in the equation. That's still an equivalent equation. Now the 1/4 times 4 is going to be 1. That cancels out. That leaves me with just x squared. over 1/4 times 1 is 1/4. Plus the 1/9 times 9 cancels out. I have y squared. 1/9 times 1 is 1/9 equals 1. This is the standard form of that equation, so it's not very pretty. And I don't think it's very useful for us to even put it in this form, but I just want you to see it. So it's like x squared over 1/4 plus y squared over 1/9 equals 1. What's the meaning of that 1/4 and 1/9? Well, they're really just the squares of the x-intercept value and the y-intercept value that are at the for the vertices and covertices of this ellipse. So we didn't need it, but there it is. It's the graph that we're most concerned with here. And let's see if we can get that equation. There's my graph squeezing in at the top. And we'll go on and do the rest of the handout on another video.